Greetings, members one and all of the Salivation Nation. An 18-karat gold nugget made of plastic? What? Let's find out what this is all about. Yes, indeed. This comes to us from phys.org. It's a physics website. Pretty fascinating subject matter for sure. This was shared with me by Pamela Rice. Thank you, Pamela, for sending this to me. A very fascinating article here indeed. ETH researchers have created an incredibly lightweight 18-karat gold using a matrix of plastic in place of metallic alloy elements. Lovers of gold, watches, and heavy jewelry will be thrilled. The objects of their desire may someday become much lighter, but without losing any of their glitter. Especially with watches, a small amount of weight can make all the difference. No one wants to wear a heavy watch on their wrist, even if it's made of real gold. After a time, it becomes uncomfortable and annoying. Actually, I would beg to differ. If I had a pure gold watch, I think that would be awesome, but I probably wouldn't be wearing it every day either. Formerly a postdoc at the ETH lab, headed by Rafael Mazenga, professor of food and soft materials, Leone Van Hag set to create a new form of gold that weighs about 5 to 10 times less than traditional 18-karat gold. The conventional mixture is usually 3/4 gold and 1/4 copper, with a density of about 15 grams per cubic centimeter. That's not true for this new lightweight gold. Its density is just 1.7 grams per cubic centimeter, and nonetheless, it's still 18-karat gold. How was this miraculous lightness achieved? Instead of a metal alloy element, Van Hag, Mezenga, and colleagues used protein fibers and a polymer latex to form a matrix in which they embedded thin discs of gold nanocrystals. In addition, the lightweight gold contains countless tiny air pockets invisible to the eye. The researchers' study on the process has just been published in the journal Advanced Functional Materials, and here we can see, take a look at this. That's fascinating indeed. That is how you create plastic gold, but maintaining it being real gold. That's really wild. Here's how the researchers create the new lightweight gold. First, they add the ingredients to water and create a dispersion. After adding salt to turn the dispersion into a gel, next they replace the water in it with alcohol. Then they place the alcohol gel into a pressure chamber where high pressures and a supercritical CO2 atmosphere enables miscibility of the alcohol and the CO2 gas. When the pressure is released, everything turns it into a homogeneous, gossamer-like aerogel. Heat can be further applied afterwards to anneal the plastic polymers, thus transforming the material and compacting it into final desired shape, yet preserving the 18-karat compositions. So the properties of the plastic workpiece is as follows. The gold has the material properties of a plastic. Mazenga says, if a piece of it falls into a hard surface, it sounds like plastic, but it glimmers like metallic gold and can be polished and worked into the desired form. That's really fascinating. There's a little video. I'll post a link to this article in the description below where you can watch that. The researchers can even adjust the hardness of the material by changing the composition of the gold. They can also replace the latex in the matrix with other plastics such as polypropylene. Since polypropylene liquefies at some specific temperature, plastic gold made with it can mimic the gold melting process, yet at much lower temperatures. Furthermore, the shape of the gold nanoparticle can change the material's color. Nanoplatelets produce the gold shimmer, typical shimmer, while spherical nanoparticles of gold lend the material a violet hue. Can you imagine a coin made of this? As a general rule, our approach lets us create almost any kind of gold we choose, in line with the desired properties, Mazenga says. So for watchmaking and electronics, that Mazengas points out that the plastic gold will be in particular demand in the manufacture of watches and jewelry. It is also suitable for chemical catalysis, electronic applications, or radiation shielding. The researchers have applied for patents for both the process and the material. Mazenga's scientists had already made a name for themselves some time ago with the lightest gold in the world, gold that weighed so little it could float atop a cappuccino froth, but the material was too unstable and couldn't be worked. This time we set ourselves the clear goal of creating a lightweight gold that can also actually be processed and used in most of the application where gold is used today. The only problem with that is, people will find it and realize, this thing is way too light to be gold. So there's going to have to be a massive education campaign. And how would you test it? That would be I guess probably the same way as you would normal. But how would these electromagnetic testers, how would they gauge the plastic in it? Very interesting indeed. Now, obviously, because of the plastic fill, there's much less of it, which means that watches could be cheaper. But the whole point of a gold watch or gold jewelry is the amount of gold in it. If you make it lighter by infusing it with plastic, that kind of defeats the purpose, in my view. And by the way, the only reason why 18 karat gold is for strength. Why you put copper and the like and everything in it. If you use plastic as well, to me, that doesn't imply strength. It only implies lightness. But nonetheless, it is an interesting and fascinating study. And here's what a piece looks like here. Really interesting indeed. It does look like gold, but it sure does. But nonetheless, what are your thoughts of this story? Precious metals and technology and how they're doing it. But in this case, I think it's kind of, in my view, it's sort of defeats the purpose of what gold is about. Part of what makes gold special is that weight, and it's the fact that it doesn't react. If you marry it with other materials such as plastics, what's that going to do? How is that going to? There's going to be some reaction here. It'd be interesting to see how that lives up, or the lifespan. Plastics can break down in time as well, and so these plastics with gold, what will that do to the composition of it in due course? A very interesting and fascinating study indeed. Thanks again to Pamela Rice for sending this along to me. I'd like to extend a multitude of gratitude to you all for watching, and encourage you to please rate, share, comment, and subscribe.